Welcome dear students to this program. Today we are going to discuss from class 9 mathematics book chapter 10 from circle part 5. Dear students, today we are going to discuss about equal chords and their distances from the center of the circle. So before going to discuss about this, let's know what do we mean by distance of a point from a line. So to get this, let's see how many lines can be drawn from a point outside a line to the line. So here is the figure. AB is a line, and on this line we have infinitely many points like L1, L2, L3, M, L4, L5, L6 and etc. etc. So that means we have infinitely many points of the line AB, and if we consider a point outside the line, that is O, how many line segments we can get by joining that point O and the points on line AB. You see, we have lines OL1, OL2, OL3, OM, OL4, OL5 and OL6 in this figure. And we can have many more than that line segments. And if we measure these line segments, which is the least, the length of which line segment is the distance of the line AB from the point P. So we have so many distances. So out of these measure of these line segments, which will be considered as the distance of the line AB from the point P. Let's see here. If we consider only one line segment which that is fixed for any distance, that is the least distance. Here OM is the least distance and that is perpendicular to AB. So we can say that the perpendicular from P to AB, namely PM, will be the least. And this least length PM is defined to be the distance of AB from P. So from all this discussion, we can get a definition of the distance of a point from a line. What is the definition? The length of the perpendicular from a point to a line is the distance of the line from the point. So as you see in that figure, that the perpendicular distance OM is the distance of the point O from the line AB. Now let's see the different chords of a circle. If we see AB, XY, MN, PQ are different chords of a circle. So how many such chords we can draw? We can draw infinitely many chords. So why it is here? If you see, O is the center and the chords are away from AB, and then at some distance XY, then at some more distance MN, and at some more distance PQ. So as we observe here, if the distance of the chords vary or the distance of the chords increase from the center, their length are growing smaller and smaller. That means we can say that longer chord is nearer to the center than the smaller chord. As you observe here in the figure, the same can be proved. How to prove? Let's see. Here is a circle with center O, and let AB and CD are two chords OM is perpendicular to AB and ON is perpendicular to CD. Longer chord, so let the longer chord is AB. AB is greater than CD. These are the chords of the circle. Now, if we join OA and say OD, join OA and OD. Now, these two are radii of the circle. So, OA is equal to OD is equal to R. Now, in triangle OAM, this is right angle triangle. So, we can say OA square is equal to OM square plus AM square. Similarly, in triangle DON, we have OD square is equal to DN square plus ON square. ON square plus DN square. As OA is equal to OD, so OA square equal to OD square. So from these three, we conclude that OM square plus AM square is equal to ON square plus DN square. As you see, this OM is perpendicular to AB, so OM bisects AB, that means AM is half of AB. So in place of AM, we can say half of AB. So OM square plus half of AB square, that is equal to ON square plus half of, and DN is half of CD. So this one. As you see, AB is greater than CD, that means half AB square is greater than half CD square. As half AB square whole square is greater than half CD whole square, then to maintain this equality, we must have OM square less than ON square. So OM square must be less than ON square. Hence, we can say OM is less than ON. That means the AB, what is OM? OM is the distance of AB from the center. So distance of the center of AB is less than the distance from the center of CD. So as we see here, longer chord is nearer to the center than the smaller chord. From this, we can have another result. What is that? The diameter is the longest chord. From this, we can say the diameter is the longest chord. How? As you see, compare two chords. One is passing through O, that is the diameter, and another is CD. Definitely, the distance of CD from the center of the circle O is OM, and distance of AB from the center of the circle O is 0 here. Literally it is 0. That means we have no other positive number less than 0. So as this is the least distance from the center, so it is the longest. So as AB is at least distance from center, so it is longest chord. So here we saw that for different length of chords, the distance from the center are different. So what about the equal chords? Is there any relationship between the length of chord and their distance from the center? Yes, that is stated by this theorem. Equal chords of a circle or of congruent circles are equidistant from the center or their respective centers. So here, what is the figure for this theorem? Here we have two chords AB and CD with center O, and OM, ON are the perpendicular distance from the center. So we can say that here it is given O is the center of the circle, AB and CD are two equal chords, OM is perpendicular to AB and ON is perpendicular to CD. So this OM, the length of OM is the distance of AB from center O, and length ON is the distance of CD from O. So what to prove? We have to prove that these distances are equal. That means OM is equal to ON. So how to prove? Let's see. Here, to prove OM is equal to ON, we need two congruent triangles. For congruency, we have some constructions. What is the construction? Let's draw OA and OC. Now we have two triangles. Let's see whether they are congruent or not. OM is perpendicular to AB and ON is perpendicular to CD. As we know, the perpendiculars drawn from center onto the chord bisects it. So we can say CN is equal to DN, that is equal to half CD, and AM is equal to BM, that is half AB. So let's see the congruency of two triangles AOM and triangle CON. So what are they? The respective parts which are equal are OA is equal to OC, or these two are radii of the same circle. Now AMO angle and CNO angle are right angles, as OM and ON are perpendiculars drawn from O to the chords. Now AM is equal to CN. Why? Because AB is equal to CD, so their half AM is equal to CN. As we have here right angle and OA, OC are hypotenuse, and AM and CN are sides, so we can have the congruency of triangle AOM and CON by RHS congruency. If the two triangles are congruent, their corresponding parts are also equal. So from that we can get OM is equal to ON. This was our to prove part. So here we proved that the equal chords are equidistant from the center. Then what is the converse of this theorem. The converse of this theorem states chords equidistant from the center of a circle are equal in length. Okay, so the figure is just like as same as that we discussed previously. Here AB and CD are two chords given, and their distances, perpendicular distances OM and ON are given. But here the given part is they are equidistant, means here as we see OM and ON are equal. Then we have to prove AB and CD to be equal. So what to write? Let's see. Given part, O is the center of the circle, AB and CD are two chords. In previous one, it was written AB and CD are two equal chords, but here they are only chords. And OM is perpendicular to AB and ON is perpendicular to CD, and OM is equal to ON as they are equidistant from the center. Then what to prove? We have to prove that the chords are equal, means length of chord AB is equal to length of chord CD. To get this, again, as AB and CD are two chords and OM and ON are the perpendiculars drawn from the center onto it, so they are bisected at M and N respectively. So as a result, AM will be equal to CN. So from that, let's see, for congruency, we have to prove AM and CN to be equal. So need two congruent triangles. So we draw AO and CO here. So in construction, we can write, let's draw OA and OC. Now what to prove? To get the congruency, we know that OM is perpendicular to AB and ON is perpendicular to CD. That gives CN equal to DN equal to half CD, and AM equal to BM gives half AB. Now in triangles AOM and CON, what are equal parts? OA is equal to OC, that is radii of the same circle, and AMO equal to CNO, that is right angle, as OM and ON are perpendicular to AB and CD respectively. Then OM and ON are also equal as it is given. So we can say that triangle AOM is congruent to triangle CON, same by RHS, that means right angle triangle, hypotenuse are equal and one of their sides are also equal. So by this congruency, these two triangles are congruent. As a result, their corresponding parts are also equal. So what are the corresponding parts here? As we need AM is equal to CN. As AM equal to CN, we can say that 2AM is equal to 2CN, and 2AM is same as AB and 2CN is same as CD. So we can say AB equal to CD. So thus we prove that the chords equidistant from the center of the circle are equal. So by using these two theorems, we can have some more results to prove. What are they? Let's see. If two intersecting chords of a circle make equal angles with the diameter passing through their point of intersection, prove that the chords are equal. See, a circle is there. We have two intersecting chords AB and CD. This point of intersection, let it be P. The diameter through this point of intersection, say XY, bisects the angle AP D. Let's see what is given. O is the center of the circle. O is the center of the circle. Chords AB and CD intersect each other at P. Now, OP diameter makes angles with chords such that angle APY is equal to angle DPY. Now, what to prove? We have to prove that AB is equal to CD. So, to prove this to be equal, we need again two congruent triangles. For that, we need construction, that is, draw perpendicular from O to CD as ON and from O to AB, that is OM. So, we can say construction OM is perpendicular to AB and ON is perpendicular to CD. Now, let's see how to prove. In triangle OMP and triangle ONP, what are equal? Given that angle OMP is equal to angle ONP equal to 90 degree, as these are perpendiculars drawn. And again, angle APO or APY is same as MPO. So, MPO is equal to same as NPO. So, NPO. This is given. Now, OP is common side. So, by angle side congruency, triangle OMP is congruent to triangle ONP. As these two triangles are congruent, we can say that OM is equal to ON. By, in short form, we can write CP, CT. As OM and ON are distances of the chords from the center, so as AB and CD, OM and ON are the distances of AB and CD from the center. So, we can say as AB and CD are equidistant from center O, this implies AB is equal to CD. As these are two chords equidistant from the center, So they must be equal. So dear students, today we discussed about the chords and their distances from the center of the circle, and we learned that when the distance of the chord is shorter, then its length is longer, and if the distance are equal, then their length are also equal and their converse are also true. I hope you understand all these discussions. Have a good day. Thank you.